Hi everyone, my name is Nilufar. I'm a third-year PhD researcher at Aston University in Birmingham, UK. Today, I'm going to talk about my PhD project. I will start by introducing the problem and motivating the research question. Then I will present the progress I have made so far. And finally, I will discuss the next stage of the PhD and the areas where I'm seeking guidance. Various real-world systems involve strategic competition over congestible resources. Providers make decisions, users respond strategically, and congestion couples their behavior. This motivates a question. How can competing leaders learn optimal policies under congestion, competition, and private follower heterogeneity? Now I illustrate the framework using EV charging as a test bed. In this setting, charging providers act as leaders, while electric vehicles, the EVs, act as strategic followers who choose routes and charging decisions to minimize their own cost. Congestion arises both on the roads and at charging stations, and also there is a competition among providers. This leads to my research question. How can competing charging providers learn optimal pricing, placement, and capacity policies when drivers are strategic learning agents with heterogeneous and private preferences? Up to this point, I have modeled the problem within an assumed equilibrium framework using a three-level Stackelberg game. At the lowest level, users make routing and resource selection decisions to minimize their individual cost. At the intermediate level, competing providers make short-term decisions such as pricing to maximize utility under competition. At the top level, one provider makes long-term decisions such as placement. The key feature is the hierarchical feedback structure, where leaders anticipate equilibrium responses from both users and competing providers. This framework leads to a subgame perfect Nash equilibria. However, it also has important limitations. It assumes a static environment, homogeneous users, and most importantly, equilibrium is analytically imposed rather than learned. The next stage of my PhD is to move toward a more realistic setup with heterogeneous drivers who learn in a decentralized way within non-stationary environments. Most importantly, instead of imposing equilibrium, I aim to study how equilibrium behavior emerges from learning dynamics. Moving to the multi-agent reinforcement learning, the key question becomes how to design the learning framework. I need guidance on the best candidate learning dynamics, including no-regret, policy gradient, two-time scale, and mean field approaches to have outcomes that are stable and interpretable. Another challenge is how to evaluate equilibrium when it is learned rather than solved. I'm seeking guidance on which equilibrium proxies best characterize meaningful equilibrium behavior under non-stationary learning dynamics, including measures such as CCE, exploitability, best response gap, and learning stability. Another key question is how to evaluate efficiency under decentralized learning and competition. I consider several candidate metrics, including total welfare, price of anarchy, equity, and resource utilization. However, I seek guidance on metrics that are most meaningful and robust in non-stationary learning environments. Thank you very much for your time and attention. I look forward to your questions, feedback, and guidance.